Okay, YouTube, in our last video has been looking at how we can expand a binomial very, very efficiently using the binomial theorem. In this video, what we're going to do is really look at how we can single out a particular term in some binomial expansion or some binomial to a higher power. So taking a look at this example is kind of exactly what I mean. It says find the sixth term in this expansion of a plus 2b to the eighth power. And so if I were to do all of this, what would the sixth term be? And I'm just going to say, you're crazy if you think that I'm going to do all of that. And so what we're going to do is we're kind of look at the pattern that we've seen with our binomial theorem in the first place. So first things first, when we look at our binomial theorem, here it is right here. We say really it is just the sum of all of the terms in this sequence right here that's defined by this rule. And so we have our binomial coefficients given by Pascal's triangle, and that's this thing right over here. But the important thing to recognize is that n, the power that we're raising this to, with respect to where that lies in Pascal's triangle, okay, say it n to the fourth power, if we were to raise x plus y to the fourth power, we would go to the fourth row. That's really the fifth row here. And what you notice is we have n choosing r, where r starts at 0 and goes to n. So basically, I just want to kind of show you this pattern here. Because you're starting at 0, if I said, hey, you're going to the fourth row, and so r ends at 4, that's what you're going to end at here. R starts at 0, 0, 1, 2, 3, and then end at 4. Cool. We're cool? Yeah, we're cool. Okay, so here's the deal. In the fourth row, you count how many terms there are. There's actually 1, 2, 3, 4, 5. There are 5 terms. This is the weirdest thing. And in the third row, there are 1, 2, 3, 4. Well, of course, there are 4 terms, and the reason why is because this value of r. Let's see if I can write on this guy here. This value of r, in terms of what term it actually is in the expansion here. If I were to see in the third row here, if I said go find the third term, we say 1, 2, 3. You notice that the value of r is actually 1 less than the term number that we actually get here. So one thing that I want to make sure I write here is this. We're going to go pick on one term, and what I know is that term has the form n choose r, x to the n minus r. I know it has this, y to the r. And this is for any expansion x plus y to the n power. This is very true that it is the sum of all of these things right here, but this is our term. Every term has this form. So what we're going to say is r is 1 less in value than the term it is you seek. Okay. So the other part of this expansion business here is this. When we go back and look at this binomial theorem here also, what you're going to see is this. The value of r is pretty important in terms of, find the sixth term. Well, then r is equal to 5 because it's 1 less than that. When you go back and look at this here, we see that it's x to the n minus r, y to the r. And so one thing I want to indicate here is that with respect to what you get on in any individual term, whatever the power is here, it should be the same as the r value that you're looking for here, which, by the way, you guys, is the same as 1 less than the term number of the thing you're looking for. So in terms of why this is important, what I'm going to tell you is this. Now that I have all this information, find the sixth term of a plus 2b to the eighth. What I'm going to say is that it has to be in this form, n choose r, x to the n minus r, y to the r. That has to be my term. And one thing I know here is this. N is 8, okay? R is equal to 5 because that is 1 less than the term number that I'm finding here, okay? My x-like thing, I could say, is a. My y-like thing is 2b, okay? Well, I know all of this just by looking at this. And I would say that all of this now I could piece together. And so essentially we were going to get 8 choosing 5. And we're going to get now our x-like thing, which is a, to the n minus r. Now our n is 8 and our r is 5. So I get 3. So I'm going to share an interesting fact with you here in just a second though. And then my second thing here is 2b. Now these were the two terms we had in the first place, so this really isn't the mystery here that you get a and 2b. But this is to the third power, and then this is to the fifth, because this 5 here has to be the same as this. So remember how I said that these two have to be the same. What I always do when I fill these out, like if I would have said 8 choose 5, like I would have known that. I would have said, hey, this here, and we say this is a and this is 2b. I can see that that's what my term values are up here. I would have just filled in the 5 first. Like I would have filled this in first, and I would have said, oh, hey, these two powers here, I was told they always have to add up to be the total power anyways, like 8. So this is going to have to be a 3 here. And so that being said, what we're going to do is we're going to find 8 choose 5. And we're going to say a to the third, 2b to the fifth. As a matter of fact, 8 choose 5. We'll find that here in a second. I know that a to the third, let me undo that there. Oops, Get my pen tool back out. We just get a to the third, and then we get 2 to the fifth, which is 32, b to the fifth here. And so let's go ahead and find on our calculators here, 8 choose 5. Get my calculator open. So 8 choose 5. Sorry, I adjust the contrast here just a couple times. Remember, you're going into your math menu. You want to type in 8 first. So we're going to say 8 math. We're going to scroll over to probability, go down to our combinations, and choose 5 here. And we get 56. So what we end up with here essentially is this: 56 times a to the third times 32b to the fifth, which you can see is, probably a pretty extensive number here. 56 times 32, not one that I care to do in my head right at the moment. We say 1792. We say 1792 a to the third b to the fifth. Now we were talking through this one, so this took a while. We're talking through it, but I'll tell you what, if you can recognize here n and r, then you're in really good shape. That's all I gotta say about this. So that being said, let's take a look at this. It says find just the coefficient, of the term a to the 6th, b to the 5th in this expansion here of 3a minus 2b to the 11th. So without writing all of this out, what I want to do is I want to indicate that, again, we have n choosing r, but they were telling us here that we get a to the 6th, b to the 5th on this term right here. And so what I know is the only way I'm going to get a to the 6th, b to the 5th in my expansion, where I have to have 3a here, and this is going to be a negative 2b here. Remember, this has to be 3a, let me write it here, 3a plus 2 plus negative 2b to the 11th. It has to be written as a sum. But we get negative 2b here. If I have a to the 6th and b to the 5th, then that means that this would have to have been a 6, and this would have had to have been a 5th. And if that's a 5 right there, then I know it matches up with my r. And I know that n here, n is the total of these two things combined. So in this case, we have n is 11, and our r value here would have to be a 5, just by this indication right here. And so we would say that we get n choose r, we're going to get 11 choose 5, 3a to the 6th power, negative 2b to the 5th power. Here we go. So we say 11 choosing 5. Go ahead and evaluate this on a machine. We 11 choosing combinations of 5. We get 462. So 462 is our coefficient on Pascal's. We say we get 3 to the 6th here, 3 to the 6th, a to the 6th, times negative 2 to the 5th. I'm going to go ahead and evaluate that one as negative 32, b to the 5th. So now let's go ahead and multiply our coefficients. One thing's clear, we get a negative term coefficient here. And because we just want the coefficient here, I'm going to take 462. So 462 times 3 times a negative 32. And I'm just going to record this here. We get negative 44352. So negative 44352 is the coefficient of the a to the 6th, b to the 5th term, essentially. Okay, cheers.